The cosmos, a vast expanse of galaxies, stars, and nebulae, appears undeniably real. Yet profound theoretical physics suggests this perceived three-dimensional reality might be an elaborate projection. An observer traversing deep space might gaze upon celestial bodies that are merely shadows cast from an unimaginable boundary. Consider the profound silence of the vacuum, a canvas for this cosmic theater. The universe's apparent solidity, its fundamental forces, and the intricate dance of matter could be an emergent property. The laws governing this reality would be encoded not within its volume, but upon a distant, ultimate surface. The concept originates from the enigmatic physics of black holes. As matter falls into these gravitational wells, information about it seems to be lost. However, quantum mechanics dictates that information cannot truly vanish. This paradox led to a radical reinterpretation of space-time itself. At the heart of this idea lies the event horizon, the boundary beyond which nothing, not even light, can escape a black hole's gravity. This two-dimensional surface acts as a repository, seemingly storing all information about the three-dimensional space it encloses. It is a cosmic screen, not a void. The holographic principle proposes that the information describing a volume of space can be entirely contained on a lower dimensional boundary surrounding it. This defies classical intuition, where volume scales differently than surface area. For the universe, this implies our 3D reality is a reconstruction. Imagine every particle, every star, every galaxy within the observable universe. All their properties, their positions, and their interactions could theoretically be encoded as perturbations on a remote, two-dimensional cosmic horizon. The physical universe would then be a macroscopic hologram. This isn't merely a philosophical abstraction, it's a deep implication of quantum gravity. The intricate structure of space-time, the very fabric of existence, might not be fundamental. Instead, it could be an illusion, a sophisticated projection arising from information etched onto a distant surface. The information encoded on this cosmic boundary is not merely data points, but the very degrees of freedom that define our reality. It's akin to the pixels on a screen, which individually are flat, but collectively render a complex, dynamic image. Each pixel on the universal horizon would carry immense complexity. The projection itself would be seamless, without any detectable seams or flicker in our perceived reality. The immense scale of the universe means these informational pixels would be unimaginably small, far beyond current observational limits, ensuring the illusion of continuous space endures. This framework offers a new perspective on fundamental forces. Gravity, for instance, might not be a force at all, but an emergent phenomenon. Its pull could be the consequence of changes in the informational entropy encoded on the holographic boundary, dictating how objects appear to interact in the projection. The very fabric of space-time, instead of being a continuous manifold, could be granular, built from discrete informational units. This granularity would become apparent at extreme scales where current physics breaks down. It suggests a quantum pixelation of reality itself, though unobservable directly. Consider the universe's expansion. If reality is a projection, then the expansion could be interpreted as the holographic screen itself growing, or perhaps the resolution of the projection increasing over cosmic time. This offers a novel way to visualize the stretching of space. The uniform distribution of the cosmic microwave background (CMB) radiation, a relic from the early universe, provides a crucial clue. Its near-perfect isotropy hints at a fundamental smoothness, consistent with a uniform information distribution on a distant, singular boundary. Such a holographic universe would profoundly redefine the nature of space-time. It would no longer be a fundamental stage for events, but a sophisticated construct, a computational output derived from a lower dimensional source. The universe becomes a grand, dynamic data display. The distinction between our everyday perception of a solid volumetric reality and this holographic model is stark. On Earth, objects have definite positions and properties in 3 dimensions. In a holographic universe, these attributes are derivative, emerging from a more fundamental 2-dimensional encoding. Consider the vacuum of space, often perceived as empty. If holographic, this vacuum is not empty but a field of projected information. The seemingly limitless expanse is a carefully rendered illusion where the void itself carries the blueprint for all structure within it, from quarks to quasars. Unlike a terrestrial photograph or movie, which is a mere representation, The holographic universe would be the actual experience. This principle challenges the very notion of depth. A terrestrial hologram creates a 3D image from a 2D surface. For the universe, it means the perceived distances to nebulae or the depths of black holes are not inherent volumetric properties, but aspects of the projection. The speed of light, c, a cosmic constant, might then be interpreted as the maximum rate at which information can be processed and rendered by this universal projection mechanism. Nothing can exceed it because it defines the update rate of the holographic display itself. The absolute silence of space, unmarred by terrestrial atmospheric interference, would be the perfect environment for such a projection. No physical medium required to propagate the illusion. It simply is an output of cosmic-scale information processing from an unseen source. Such a universe makes human attempts at measuring fundamental constants or mapping space-time akin to analyzing pixels on a screen without understanding the underlying code. The true nature of reality might be hidden not by distance but by dimensional reduction. Despite its elegance, the holographic principle faces significant observational challenges. Directly detecting the pixels of this cosmic hologram requires energy scales far beyond any current or projected technology, making direct verification extremely difficult. One potential weakness lies in the quantum entanglement of particles across vast cosmic distances. If reality is truly a projection, then the instantaneous connection between entangled particles might be a feature of the underlying 2D information rather than a volumetric paradox. The stability of this cosmic projection is also a point of inquiry. What ensures the consistent rendering of physical laws? Any glitches or inconsistencies in the underlying informational code could theoretically manifest as inexplicable anomalies in our perceived universe. Over vast timescales, the holographic data itself could degrade or shift, leading to subtle changes in physical constants. While not a catastrophic collapse, this slow decay of the underlying information would fundamentally alter the projected universe over eons. The ultimate screen for this projection, the universal event horizon, remains entirely theoretical. Its existence and precise location are unknown. If such a boundary truly exists, its properties dictate the very physics we observe, making it the most fundamental yet unseen structure. Furthermore, the energy required to maintain such an intricate, constantly updating holographic projection of a universe so vast and complex is immense. The source of this computational power is a profound question, hinting at an even more fundamental layer of existence. A universe born from a holographic principle might also imply a finite information capacity. As the universe expands, its resolution might become stretched, leading to a subtle blurring or noise at the largest scales, a gradual breakdown of the holographic fidelity. The very concept of cosmic evolution, from the Big Bang to stellar death, could be seen as a sequence of rendered states of this holographic system. The aging of the universe might not be a physical decay, but a progression through a pre-programmed or dynamically evolving informational script. If the universe operates as a hologram, then any attempt by an observer to probe its deepest layers might inherently be limited. The observer, being a component of the projection, could never truly step outside the illusion to see the underlying code without breaking the system itself. The possibility of a universal reset or reboot arises from this model. If cosmic entropy reaches a maximum, or if the underlying information becomes too diffuse, the projection could theoretically collapse and restart, perhaps erasing the current iteration of spacetime. A catastrophic failure of the holographic principle would not be a mere supernova, but a fundamental unraveling of reality. Imagine the fabric of spacetime itself pixelating or de-rendering as the informational structure supporting it begins to fail, leading to an incomprehensible dissolution. The profound philosophical implications are immense. Humanity's relentless quest to understand the universe through observation and experimentation would then be akin to analyzing a meticulously crafted virtual reality from within its own code. The objective reality would lie beyond the perceived. This model challenges the inherent bias towards volumetric reality. The universe's fundamental truth might not be found in its vastness, but in the elegant simplicity or immense complexity of a two-dimensional information surface, far removed from our direct sensory input. The sheer scale of cosmic structures, the intricate dance of galaxies, and the formation of celestial bodies would all be expressions of this underlying information. It turns the cosmos into an infinitely complex, self-rendering computational display, always consistent, always logical, always vast. The absolute silence of space then becomes more profound, not merely a lack of sound waves, but the silent operation of a universal algorithm processing information into stars and nebulae. This holographic projection continues, an ongoing cosmic revelation for those within its confines. If all is projection, what is the true nature of the observer? Consciousness itself could be a highly advanced subsystem within this grand illusion, unable to perceive the projector from within the projected space. The mind, too, becomes a product of the holographic rendering. Humanity, bound by its three-dimensional senses, diligently maps the stars, unaware its efforts might be unraveling the intricacies of a cosmic display. Every scientific discovery, every observation of celestial mechanics becomes a deeper understanding of the projection's algorithms and rendering techniques. The shimmering radiation of distant nebulae, the rhythmic pulse of quasars, these are not merely phenomena, but perfectly rendered effects. The universe becomes an unimaginably complex, continuously updated simulation, vast yet fundamentally programmatic, its grandeur a testament to its design. The drive to explore, to comprehend galactic structures and the fundamental particles is an innate response to the holographic script. It is the program itself compelling its components to seek self-understanding within its generated parameters, a self-referential quest for meaning. The universe, then, is a testament to an unseen intelligence or an emergent property of information itself, operating on a scale incomprehensible. Its ultimate projector remains the final, profound mystery, a layer beyond physical reality, perhaps forever beyond our reach. In the silent, cold expanse, the cosmos unfolds as a symphony of light and gravity, a majestic, enduring illusion. Every celestial event, every life born and extinguished, exists as part of a grand informational weave meticulously rendered across cosmic eons. If the universe we inhabit is indeed a hologram projected from a cosmic event horizon, what then defines real? And could humanity ever discern the underlying truth beyond the shimmering veil of projected reality?